Good morning. Myself, Magendiran, working as a professor in the Department of CST at Polytechnic Department. Today, I'm going to explain about one of the concepts of data structures like trees. So, first of all, we should know what is the meaning of data structures. There's a way of organizing data, how data are organized in our computers. So, for these data structures, probably we have the two main concepts that is called linear, non-linear. So, first of all, we should know what is the meaning of linear data structures. There's nothing but we organize data in the format of sequential manner. It's called linear data structures. The one more case is non-linear. Here, we are organizing data randomly. So, in this session, I'm going to explain about one of the non-linear data structures available on programming languages like trees. Okay. So, first of all, we should know what is the meaning of non-linear data structures. That's the meaning of how data are organized in random basis. So, we can traverse data at any format. So, we can go and take data. We can go and take also data at any place. Similarly, we can get back data at any places. That's called non-linear data structures. So, tree is one of the non-linear data structures concepts available on programming languages. So, one more concept also there that is called the graph. Today, in this session, I'm going to explain some of the tree concepts. So, first of all, we should know what's the meaning of tree. Tree is a non-linear data structures, that is the format of hierarchy, which consists of collection of nodes and edges. So, first of all, we should know what's the meaning of node, what's the meaning of edges. The node is nothing but data point. The edge is nothing but the link connections point between these nodes. So, in the tree is nothing but the combination of or collection of the various number of nodes and its associated edges. So, it stores the information naturally in the format of hierarchy, looking like the tree formats. Right. So, what's the meaning of hierarchy means we can have that root, child, as well as parents, grandparent concepts. The thing is, we are having some root node followed by some child node followed by its own child node. So, we have that parent, grandparent, child, grandchild logics here. So, usually we have the tree with one root node along with more number of childs. So, this is one of the example of the tree. So, in this tree, the node 2 is called the root node. Then the node 9 is the child of that node 2. So, probably node 2 is the child of node 9. So, here this root node is acting as a grandparent of the node, this node 2, 1, 7, 2, 44. So, probably similarly the node 12 is a parent of the node 1, 7, 2. So, this is one of the example of tree. So, I would like to show one more example of the tree, that is, for example, the book tree structures. So, here the book is the root node, the chapters are similarly the child node from the book, then the sections 1.1, 1.2, 2.1, 2.2 are the subnodes of the chapters. Then these sections 1.2.1, 2.2, 2.1, 2.2.2 are the leaf nodes, which are available at the last phase of this tree. Next concepts in this tree. Before we discuss about the tree, we should know the various tree terminologies. We can call that's the technical terms of the tree, because without knowing all these terms, we can't learn the tree structures. So, if you take the tree, the child, siblings, degree, internal nodes, leaf node, levels, height, depth, subtree, forest, root, edge, parent, grandparent, grandchild are some of the basic terminologies of the tree technology. Let me explain all these terminologies one by one in the subsequent slides. Okay. So, first of all, we should know what's the meaning of the root node. Right. So, the root node is available everywhere in the tree. There is the first node of the tree, right? So for the tree, we have only one root node, remaining are the child nodes. Next one, the edge. So what's the meaning of edge? That's nothing but the connecting link between any two nodes is called the edge. So we have previously we have seen one tree that consists of the plenty of nodes along with the edges. So if you have a number of nodes, you may have n-1 number of edges. The thing is, all the nodes should be linked through the edges. So in a tree with a number of nodes, there should be exactly n-1 number of edges as per the definitions given. Next one, the parent. The node which has a branch from where it derives a node, that is called the parent node. So probably in the tree we have the parent nodes. The root is also the parent of its child. So in a tree, the parent node can have any number of child nodes. So in this example, if you take this example, this A is the root node, B and C are the child node of that node A. If you take one more example slide, here A, B, C, D, E are the parent nodes. Because of if you take that E, we have the children of this node E. I and J are the children of the node E. So whereas if you take this node F, this is not a parent node. Because of the node F, in node F we don't have any children. So if you take the node D, this is not a parent node. Since we don't have any children from this node D, right? The next concept is, the next T terminology is called child. So as we discussed already, the node which is the descendant of some of the node is called the child node. So all the nodes except the root node are child node. Because the root node is never act as a child node. Except the root node, all should be comes under child node. The next logic is siblings. So we should know what's the meaning of siblings. The siblings are nothing but the node, the children which are coming from the same parents. That is called the siblings. The nodes which belong to the same parent are called the siblings, right? Like our brothers and sisters logics. The next tree terminology is called the degree. So what's the meaning of degree? Right? In degree we have the two classifications. One is called the degree of node, then the degree of tree. So first of all, we should know what's the meaning of degree of node. The degree of node is nothing but the total number of children of that corresponding node. If you take any node, just count the total number of children from that node. That is called the degree of node. So if you take that node B, we should count number of children from this node B. Let's say, for example, the D, E, F are the children of the node B. That is the count of that node B is 3. The 3 is the degree of node B. If you take the node C, G and H are the children. So we have the two children from this node C. So the degree of node C is only 2. Next step, that is called the degree of tree. So what's the difference between degree of node and tree means the highest degree of the node among all the nodes in the tree. If you take this tree, within this tree, first of all find out the degree of node for each and every individual node in this tree. Then among other things to find out the highest degree of the node among all the trees, among all nodes of the tree. That is called the degree of tree. If you take this example tree, the degree of node, if you take the degree of node J, that's a 0. The degree of node E, that's a 2, because of the two children from this node E. Similarly, if you take the degree of node G, that is a 1. If you take the degree of node C, that's a 2. The degree of node B, that's a 3. If you take the degree of root node A, only for 2 children, 2. So among these calculations, the node B, which has the maximum number of children, that is a 3. That is again the degree of the tree. Just find out the degree of a node for each and every node of the tree. Then find out the maximum number of degree of the node, that is the degree of the tree. That's the highest degree of the node among all the nodes in the tree. That's called the degree of tree. Next one, the internal node and leaf node. So we have the two logics here. So we know what is the meaning of node, what is root node, what is child, what is parent, then what is internal node. There is nothing but the node which is lies in between that root and the children. That is called internal node. Probably there is a in between the two nodes. That is called the internal node. The node which has at least one child is called as internal node. See, so the last one is never called as internal node. The node which has at least one child is called internal node. The internal nodes are also called non-terminal nodes. So we should know one more logic that is called non-terminal node. So what's the difference between terminal node and non-terminal node? The terminal node nothing but the last level nodes. If you take the previous examples, so the node I, J, K are called as a terminal node because of this end of the tree. We don't have any branches or child from these nodes. So this is called terminal node. Whereas if you take this D, D also terminal node. If you take that E and B, G, H, C, A are not terminal nodes since we have the branches from this node. So if you take these pictures, the node B, C are internal nodes because we have the node B from the node A also has the children's D, E, F. So the node B and the C R comes under the category of internal node and as well as non-terminal node. Right. Then next tree terminology is called the leaf node. Okay. So as we discussed already, the last level nodes are called the leaf node. The node which does not have any child or any children is called as a leaf node. So as we discussed in the previous examples, so if you take the node I, J, K, we don't have any children from the node I, J or K. So these nodes are comes under the category of leaf node. So in these pictures, the node A is a root node, then B and C are internal node or non-terminal node. If you take the node I, J, K are called terminal node or leaf node. Next, the next three terminology is known as that levels. So in our tree we may have different levels. So what's the meaning of levels? So in a tree, each step from top to bottom is called as a level of tree. If you take this tree, we may have a number of steps. We start from the root node to that leaf node. If you take that A is a root node, that's a level, first level. If you take that B and C are the second levels. If you take that D, E, F, G, H, it may be the third level. Similarly, I, J, K are the last levels. So as per this logic, we have to keep on the levels from the top to bottom order. So the first A comes under the level 0, B and C are comes under the level 1, whereas D, E, F, G, H are comes under the category of level 2. I, J, K, R comes under the category of level 3. So we have to categorize the various levels of the tree also. Okay. So as per this scenario, the levels are start from the 0 and increment by 1 at each and every level of steps. So not for levels 1, we always start with level 0, then 1, 2, 3, 4, it goes on. The next tree technology concept is height. So what's the meaning of height of the tree or height of the node? So again we have the two broad category of the height of the tree and height of the node. What's the meaning of height of the node? First of all, the total number of edges, that lies on the longest path from any leaf node to a particular node is called height of the node. So I'll explain with this live examples. If you take that pictures, this example, the total number of the height of the node is referred as the longest path from any leaf node to the particular node. So we have to start from the leaf node and go to the particular node. That's called height of the node. So based on this definitions, we want to find out that height of that very particular node. If you take this node V, we can calculate the height from this leaf node. So in this scenario, in this given tree, A is the root, similarly I, J, K are the leaf node. So we have to find out that height of that node from the leaf node to the corresponding node. So the leaf node is I, J, K. So we have that connections just between that I and E. So this is 1. Similarly, we have connections between the E and B. That's a 2. Then B to A. That's a 3. So the height of the node B is 2 because of we have to calculate the height of node from that leaf node to that particular node. This is 1 and 2. So height of that node B is 2. If you take the height of that node I, so height of the node I is 0 because of all the leaf nodes. The height of the leaf nodes are always meet by 0 because we don't have any children from these leaf nodes. So height of the node I is 0. Right? Height of the node J is also 0. The K is also 0. Right? If we go for that E, the height of the node E is 1 because of we have one edge from this node I to E and similarly J to E. Right? So for the cases we have only one edges, so the height of the node E is always 1. The height of the node B is 2 because I to E, E to B we have the 2 edges. We take the height of the node A, that's the root. We start from that person. I to E, E to B, then B to A. So 1, 2, 3. If you take this part, we have the height of the node A is 3. 1, 2, 3. If you take some other alternate path, J to E, again E to B, then B to A, that's again 1, 2, 3. If you go for the right side subtrees, if you take this level, the K to G 1, then G to C 2, C to A 3, again 1, 2, 3. If you take all the combinations, the height of the node A is always 3. So this logic is very simple to calculate the height of the node from the edges, number of edges from the leaf node to that corresponding node. That's called height of the node. Okay. The one more terms related to the height is called height of the tree. That is nothing but the highest node, the highest height of the root node is called the height of the tree. If you take that the height of the tree means is the height of the root node is always the height of the tree because of that root node has the maximum number of values. The root node which has A is the maximum value of the height. If you take these pictures, the height of the node B is 2, C is 2, whereas the A is 3. So the height of the tree is the height of the root node is also mean by the height of the tree. Next logic is that's a depth. So next term that is called the depth of the tree. The depth is completely opposite of that height of the tree. So what does the depth means? The total number of edges from the root node to the particular node is called the depth of the node. So we have to find out the edges from root to the particular node. If we go for the height, we can calculate the number of edges from bottom to top. That is the leaf node to the particular node. That is called the height of the node, height of the tree. Whereas the depth means to calculate the number of edges from root to the particular node. That is called the depth. That's opposite of the height. That's why we say the total number of edges from the root node to the particular node is called the depth of the node. Similarly, we have one more term that is called depth of the tree. That is the total number of edges from root node to the leaf node is called depth of the tree. So if you just compare the height and depth here, if you take the height, we can calculate the number of edges from bottom to top. That is leaf node to that particular node. If you go for the depth, what is it? The root node to that particular node, that is called depth. Top to bottom, that is called the depth. Right? Similarly, the depth of the tree is the total number of edges from the root node to the leaf node, that is called the depth of the tree. Right? So usually the height of the leaf node is always 0 because that starts from the bottom to top. Similarly, the depth of the root node is always 0. Right? So here the term level and depth are used interchangeably or used frequently alternatively in our discussion. So in this example tree, if you take this pictures, the height is as we discussed from bottom to top. The height of that node B is 2, the node A is 3, because we calculate remember just from leaf node to that particular node. 1, 2, 3, right? Similarly, the depth is start from the root node to the leaf node. If you take the depth of the node B, start from the node A to B. 1, we have the depth of the node B is 1, the depth of the node C is also 1, whereas the depth of the node A is 0, because we start from top to bottom. If you take the depth of the node D, that's a 2. We have A to B, B to D, 1. Similarly, E is 2, F is 2, G is 2, H also 2. If you take the depth of the node I is 1, 2, 3, 3. Similarly, the depth of node J is also 1, 2, 3. For K, again 1, 2, 3. Right? So the simple object, the height is counted from bottom to top, depth is from top to bottom. So the height of the tree is nothing but the height of the root, whereas the depth of the tree is nothing but the depth of the leaf node. Right? Just opposite of the height. The extra terms are called a subtree. So we know what's the meaning of subtree. That's a tree again within this tree. That's called a subtree. In a tree, each child from the root forms a subtree recursively. Right? If you take these pictures, we can be able to see that more number of subtrees here. See, if you take the node A, so this one is a subtree. Okay, the B, D, E, F, I, J are one of the subtree of the node A. The same way, the node C, G, K, H are one more subtree of the node A. So for if we take the node A, we have two subtrees 1 and 2. If you take the node B, again these combinations E, I, J are subtree of the node B. Right? So this is subtree of the node B, whereas these two things are subtrees of the node A. Right? The next term that is called the forest. The forest is nothing but the set of or collection of or number of disjoint trees. Clear? So you should know what is the meaning of disjoint tree. The thing is, we have the tree without any joint, without any connections here. If you take these pictures, if you take only for subtree, this B, D, E, F, I, J, and C, G, K, H. So these two things are the subtrees of the node A, whereas we don't have any link between these subtrees. Right? Disjoint tree, that is called a forest. So the collection of disjoint tree are known as a forest. Right? Because we don't have a link between these two subtrees, that is called a forest. The forest is nothing but set of or collection of number of disjoint tree, that is called a forest. Okay. So almost we covered all the basic tree terminologies, all the important technical terms available on the logics of tree. Because of we are using all the terms frequently in the discussion of the tree logics.